Picture yourself as an astronaut, tethered to the International Space Station, performing critical repairs. Earth spinning majestically below, a breathtaking view of our blue planet. Suddenly, without warning, a tiny fleck of paint, smaller than a grain of sand, almost invisible to the naked eye, zips past your helmet at an unbelievable speed, over 17,500 miles per hour. It's a cosmic bullet with your name on it. At that speed, even a speck, seemingly harmless, can punch through metal or shatter a helmet visor, jeopardizing everything. This is not science fiction. This is the very real reality of space junk. Millions upon millions of human-made fragments orbiting our planet, all traveling at bullet-like speeds, posing a constant threat. Every launch, every mission leaves behind debris, bolts discarded during assembly, tools accidentally dropped during spacewalks, fragments, shattered remains of defunct satellites, slowly but surely turning low Earth orbit into a hazardous minefield, a cosmic shooting gallery. The International Space Station, a symbol of international cooperation, has had to dodge debris dozens of times, performing emergency maneuvers to avoid catastrophic collisions, and its windows, offering unparalleled views of Earth, are scarred by countless micro-impacts. Each mark, each tiny crater, is a stark reminder: the threat is real, it's present, and it's growing exponentially. Space junk is the unfortunate byproduct of our technological achievements, our ambition to explore the cosmos, but also undeniably a consequence of our collective neglect and lack of foresight. We've carelessly turned the final frontier, once pristine and untouched, into a junkyard, a dumping ground for our spacefaring endeavors, and the consequences of this orbital pollution are rapidly catching up with us. The problem began innocently enough with the launch of the first satellite, Sputnik, a symbol of human ingenuity, and has only accelerated with each passing year, with the ever-increasing number of satellite launches. In the vacuum of space, there's no atmospheric drag, no air resistance to slow debris down. Objects once set in motion just keep circling our planet, endlessly orbiting, a perpetual hazard. Even a seemingly insignificant marble-sized object, a tiny piece of space debris, can hit with the destructive force of a bowling ball traveling at an astonishing 300 miles per hour. The silent, unseen threat looming above us is getting louder, more pervasive, and more dangerous with each passing year. If we want to continue exploring the vastness of space and rely on the vital communication services satellites provide, we must confront the mess we've made, take responsibility for our actions, and find innovative solutions. The problem is not going away on its own, it's only getting exponentially worse, demanding immediate and decisive action. Space junk, formerly called orbital debris, is any human-made object in space that no longer serves a purpose. It ranges from dead satellites and spent rocket stages to tiny flecks of paint and metal shavings. The largest pieces, like defunct satellites and rocket bodies, are tracked from Earth, but millions of smaller fragments created by collisions or explosions are too tiny to track. Even a dropped tool or a lens cap becomes a dangerous projectile at orbital speeds. In low Earth orbit, everything moves at 17,500 miles per hour. A marble-sized fragment can destroy a satellite. It's not the size that matters, but the energy carried by these objects. This relentless barrage threatens every mission and satellite in orbit. Space junk is a persistent, invisible danger circling our planet. Our orbital junkyard, a sprawling collection of discarded remnants, didn't appear overnight. It's a problem that has been gradually accumulating over decades. It's been growing steadily since the launch of Sputnik in 1957, the first artificial satellite to orbit our planet, marking the dawn of the space age. Every mission, while pushing the boundaries of human exploration and knowledge, inevitably left behind hardware. This includes dead satellites, now silent sentinels adrift in the cosmos. We also have spent rocket stages, the discarded vehicles that propelled spacecraft into their designated orbits, and even abandoned tools, lost during spacewalks, now orbiting alongside everything else. For decades, the big sky theory, the idea that space was so vast it could absorb anything, led us to ignore the growing problem. We were assuming space was simply too vast to worry about the consequences of our actions. But launches multiplied rapidly, especially during the intense space race of the Cold War era. And as launches increased, so too did the amount of debris accumulating in orbit. Explosions, often caused by leftover fuel or battery failures on defunct satellites, shattered these objects into thousands upon thousands of dangerous fragments. Furthermore, anti-satellite missile tests have created even more debris, adding significantly to the problem. These tests are polluting valuable orbits for decades to come, with long-lasting consequences. The more junk we have in orbit, the higher the risk of collisions between debris and operational satellites. And each collision in turn creates even more debris, exacerbating the problem further. This self-perpetuating cycle, often referred to as the Kessler syndrome, means the problem can grow exponentially, spiraling out of control at an alarming rate. This could happen even if we were to stop launching anything into space today. Our garbage is now actively creating more garbage through collisions and fragmentation. This is turning space into a ticking time bomb, a dangerous environment for all. The threat is no longer just a theoretical possibility or a distant concern, it's accelerating at an alarming pace, demanding immediate attention and action. This self-perpetuating and runaway cycle has a name, a term that sends shivers down the spines of space agencies worldwide: the Kessler syndrome. It's a scenario that paints a grim picture of our future in space. Back in 1978, NASA scientist Donald Kessler, a pioneer in the field of orbital mechanics, issued a stark warning. He predicted that once the density of space debris reaches a critical tipping point, a single collision could trigger an unstoppable chain reaction of cascading impacts. Debris generated from one crash doesn't just disappear, it causes more crashes, creating a domino effect of destruction. This debris then spreads rapidly like a cloud of shrapnel through already crowded and vital orbital lanes. Imagine a multi-car pileup on a foggy highway where visibility is near zero and reaction times are limited. Except in this scenario, the cars, or rather the debris, are hurtling through space at speeds of up to 17,000 miles per hour. If the Kessler syndrome truly takes hold and spirals out of control, some crucial orbits around our planet could become completely unusable and inaccessible for generations to come, effectively cutting us off from space. Launching new satellites to improve global communication or sending astronauts on scientific missions would be akin to playing a dangerous game of Russian roulette, with the odds stacked heavily against success. Our access to space, the gateway to countless opportunities and discoveries, and the vital infrastructure we rely on daily, from communication networks to GPS navigation, could grind to a complete and utter halt. Some leading scientists and space debris experts now believe that we're dangerously close to, or perhaps have already reached, this critical density in certain heavily trafficked orbits. The amount of space debris is now multiplying at an alarming rate, far faster than it's being naturally removed and cleared away by the effects of atmospheric drag. We're not just passively adding to the ever-growing pile of space junk. The pile is actively growing and expanding on its own, fueled by collisions and fragmentation. The potential consequences of this cosmic chain reaction are not just concerning, they are potentially catastrophic and dire for our future in space. We must take decisive action, and we must do it now, before we reach the point of no return and lose access to the vast frontier of space entirely. Space junk has already caused disasters. In 2009, an American satellite and a defunct Russian satellite collided, creating thousands of new debris fragments. In 2007, China's anti-satellite missile test shattered a weather satellite, adding over 3,000 trackable pieces and countless smaller ones. Some debris even survives re-entry. In 1978, a Soviet satellite scattered radioactive material over Canada. Each incident is a warning. Active satellites, the ISS, and even people on Earth are at risk. The sky is literally falling piece by piece. We need better space traffic management and international cooperation to prevent more disasters. Why should you care? Because satellites are the backbone of modern life. GPS, banking, TV broadcasts, weather forecasts, and disaster response all depend on satellites. A single collision could disrupt GPS, global finance, or emergency communications. Earth observation satellites help us monitor climate, manage crops, and predict disasters. Losing them would blind us to changes on our own planet. Even national security relies on satellites for communication and surveillance. Space junk doesn't just threaten astronauts, it threatens our entire digital world. The risk is growing, and the consequences would ripple through every aspect of society. Our connected world depends on safe, reliable access to space. We can't afford to ignore the danger above our heads. So what can we do? The first step is prevention, designing satellites to deorbit safely at the end of their lives. But we also need to clean up what's already there. Active debris removal is underway. Nets, harpoons, and even lasers are being tested to capture and deorbit junk. Missions like Remove Debris and Clear Space One are proving these concepts can work. But real progress requires global cooperation and investment. International treaties must make debris mitigation mandatory. We need to see space as a fragile environment, not a dumping ground. Just as we protect our oceans and forests, we must protect our orbits. The future of exploration and our modern world depends on it. Cleaning up space is a global responsibility. Let's get to work.